Okay. Sign analysis charts is what we're going to focus on today. Guys, lesson is going. Okay, lesson is going. Okay. Also, you guys, I don't move the tables ever, right? I don't touch them. So those that you guys are like hurting your necks from seeing, you can move your tables. Like Ethan doesn't have to sit with his back to the board. But you guys are almost adults, you can make that choice. Okay, just saying, you can move things so you guys can see better. Okay, I'm just saying. All right. Now, you guys, because of last year, anytime I say the word sign, you immediately think trig. But the majority of the time in calculus when I say sign, I'm not talking anything about trig, I'm talking SIGN sign, plus or minus sign, okay? Now, what we're going to do is we're going to talk about how to look at, on our ultra lava papers, we have our derivative characteristics table. That's like the first table we did, and it's on the front side all about, like, if it's increasing on the original, then it's positive or negative y value on the derivative, things like that. We're going to talk about that a little bit more today. Okay, so let's say I have a function like this. F of x equals, let's do x cubed, 15. Okay, and I want to find the critical values. Can anyone raise their hand and remind me? No, not a question, statement, fine. Can anyone raise their hand and remind me what a critical value is? Can somebody raise their hand and remind me what a critical value is? Ethan?
It's like a x-intercept.
Nope.
It's the derivative.
Zero and undefined of the derivative. Remember, we have a new definition for critical values this year. It's any value that is a zero or an undefined value on f prime, right? Well, I learned how to find zeros last year, right? Cubics, I would go through the rational root theorem to find my possible zeros, and then I put them in synthetic division. Yeah, right? Is true, okay? So, is that what I need to start doing?
No.
Why?
It's tedious.
Well, it is tedious, but that's not why. No. Oh, I want the zeros of the derivative, not this. Critical values are zeros of the derivative, right? Not this. Good? Okay, so now let's derive that. So 3x squared plus 15x plus 18. Good?
Yep.
You have 30 seconds. Factor it.
I don't even know what 3 plus 18 is.
GCF.
Oh, I forgot those.
GC. Excuse me. Oh, yeah, might be COVID. Just kidding. It's in recording.
Oh, shut up. Shut up. Shut up. Shut up, it's so invited.
Dang it. That's right. Why does that equal to 0?
Because you're trying to find zeros.
So I'm trying to find zeros. Do I have to worry about the undefineds?
No.
Why not?
It's a derivative.
But the critical values definition is zeros and undefineds of the derivative. So why don't I have to worry about undefineds?
Because it's not like over another thing.
Oh, yeah.
I
There's
can't
no
even hear what you're
denominator.
saying, Annika. You're
There's
talking
no
so quiet.
denominator.
She says there's no denominator. That's not our only way it could be undefined, but that's probably one of our most common. But the idea is, does this family of function quadratic have a possibility of being undefined? No, I got to think of it, but it doesn't necessarily have to be that way, right? Okay, now, How do I find the zeros of that?
You just plug it up.
Plug it in? What does that mean? What am I plugging it in?
Well, you don't plug it, you
I find the zeros? How?
split it up.
You do x plus 2 equals 0.
Split it up.
X plus 2 equals 0.
Okay.
X plus 3 equals 0.
What about this factor?
And that you do.
Why doesn't that matter for the zeros?
X equals.
There's no x, meaning I can't change that in any way, so it stays at 3.
Okay, then you minus 2 on both sides.
Okay.
X equals minus 2.
Now, you know my rule, right? I'm not allowed to do anything without knowing the y. Y, can I just take each parenthesis one at a time? And why will that give me the zeros? Okay, go ahead, Trevor.
Commutative property.
Commutative property, so being like, doesn't matter what order, that's part of it, absolutely. Jack?
Separate functions.
What do you mean?
Well, like x plus 3 is a function on its own, right?
Okay, it's a function on its own, and if x plus 3 equals 0, does it matter if the rest of it is 0? No, because 0 times anything is 0, right? Anyone know what that's called? Jake?
Oh, no, I was just about to say that.
Good. No, just keep going. What were you
No,
going
I
to
was
say?
thinking, like, if there was an x in front, then x would also be equal to 0.
Sure. Yeah, if there was an x by the 3, we would have had another 0 there. Yeah.
The zero product rule.
Yeah, the zero product rule or the zero product property, which tells me that, good job, tells me that anything times 0 is 0. So if x is negative 3, I get 0 times negative 1 times 3, right? Some people think I'm plugging in a different x, but that's not what I'm doing. What I'm saying is I can take these because they're separate functions, right? And because it doesn't matter which one is 0 because of the commutative property, and the zero product property says if one of these factors is 0, the whole thing is 0. Good? Okay? That's why we're doing that. We got to get out of the habit of just doing things without understanding why we're doing them, right? Okay, so now what I'm going to do is I'm going to make a sign analysis chart, which is a fancy word for an number line.
Okay, yeah, I totally forgot how to do those.
Well, I guess that's a good thing I'm about to teach you. Yeah. Which actually surprised that some of you guys did some of that last year. It was probably with quadratic inequalities. But that's cool. I didn't realize anybody had seen that before. So cool. Now, I thought normally when I make an inequality, I mark 0. Why do you think those are the numbers I put on this thing?
Because they're the zeros.
They're my zeros, right? They're the ones that matter. Now, I solved, right? Using algebra, I solved for any possible 0 or any possible undefined, right? What that tells me is that any infinite decimal between these values is going to have the same sign. Is that fair?
Yeah.
So here's the idea of a sign analysis chart. I only need to figure out what one number's sign is in that interval, and it'll tell me the sign of all the infinite numbers in that interval.
Yeah.
Make sense?
Yeah.
Okay? Now, I don't even care what the number is. All I care is what its sign is. So if I look at negative 2.5, all I got to look at here is that factor positive or negative? If I plug in x equals negative 2.5. Positive? What about that one? What about that one? So what kind of a number am I going to get if I have a positive times a negative times a positive?
That's it.
That's it for that part.
You have to like to go a little bar, right?
No? Now hold on. Hold on. What about the other sides? Okay?
Are the opposite because
Not automatically.
unless it's outbound, it will cross
Right.
through if it's an x-intercept.
It doesn't always cross over on an x-intercept, so you still have to put in one in each interval because you can't assume, because this one is a nice cubic, but you know me, I'm going to make it a lot trickier, right? Okay, so let's pick 0. If I plug 0 in, what type of a number do I get? So 3 positives. Okay, negative 5. So positive, right? Now, here's the purpose of this, okay? Let's say this represented a particle movement. The last class period before test corrections, you guys went through hopefully that worksheet where you started looking at different types of vocab that are talking about like derivatives, right? Because we're trying to relate AP verbiage with these like derivative rules we've been doing, right? Okay, so the idea is, let's say this represented a particle's movement, and I wanted to know anywhere the particle was moving to the left. Now, left represents, on a particle on a horizontal line, left represents decreasing, right? Now, if I didn't want to look at the derivative, I could try and figure out from here where this particle is decreasing. The problem is, I'd have to put in multiple points so that I can compare them to see where it's going down, right?
If it's negative y values was decreasing, you can just.
Right, so, but it's going to be a lot easier. That's the point of this, to look at the derivative, because I only had to look at one value, and showing that it's negative tells me all of that is the decreasing on the original. Is that fair? That's the purpose of these, so that it's less work. Instead of me having to plug in multiple numbers to compare if the y values are going up or going down to find increasing and decreasing, I can just plug in single ones in these intervals, and then I know all of those are increasing or decreasing. So it is a lot less work.
So if the question asked which intervals are increasing or decreasing, that's just what it's for.
That's what this is for. So what would be the answer to this? Where would this particle be moving to the left?
Between negative 3 and negative 2.
Negative 3 and negative 2, right? Because that's where the derivative is negative, so that's where the original function is decreasing, so that's where the particle is moving to the left along the horizontal line. We're making these connections from the things we did on that derivative characteristics chart on the front of our ultralava with the AP verbiage of derivatives and things. Everybody good? Okay, now, where does this graph, where does f of x have a relative minimum?
We don't know
Nope.
that. We can use whatever theorem.
Oh, yeah, because it changes from negative to
Just somewhere in the middle.
Where does f of x have a relative minimum?
Between negative 3 and negative 2.
Nope.
F of x.
Caden?
negative 2.
Negative 2, correct. Because where does the original function's extrema happen? At the zeros, right? And I asked for a minimum, so a minimum is where my original function decreases and then increases. So derivative negative to positive. Got it? So where does f of x have a relative maximum?
At 3, negative 3.
Negative 3, okay? Where does f of x have an absolute minimum?
At negative 3.
No.
Oh, wait, negative 2.
No.
And it's still
Where
increasing.
does f of x have an absolute, did I say min or max? I don't even care. Minimum.
Negative infinity.
Negative infinity?
That works.
Negative 2.
Nope. Oh, sorry.
No.
Danica?
I don't really know because there could be like more graph where like so it can have a higher point than here.
Okay. You have a kind of the right idea. But I know about the absolute minimum. Because I know my families of functions so well.
It's negative infinity.
Negative infinity is the lowest value in my range.
Well, yeah, where x is, like when x approaches negative infinity.
Negative infinity is an idea, not a value. I cannot treat it like a number. It has no absolute minimum.
Yeah.
Yeah, because it goes to
Because it's a cubic. Cubic functions, where I don't restrict the domain, have no absolute minimum. It goes forever.
Yeah.
Which means that since it's going down forever, it doesn't go back up.
It has no absolute minimum.
What's the definition of absolute?
Somebody raise your hand and answer that. What's the definition of absolute? Very bottom.
Like the most negative value.
Most negative value? So what's the most negative value on something that goes down forever?
An idea which is a real number.
There is none. So this cubic has no absolute min, no absolute max, but it has a relative min at -2 and a relative max at -3. Good? Okay, let's do another one. This one I'm just going to give you the... I'm not going to give you the function at all. Now remember I told you we put all zeros and undefined, right?
Oh, okay.
So here's what I'm going to give you a couple minutes to do with your neighbors. I just want you to start making a list, and we're going to play the popcorn game, right? Where someone comes up and just hands the marker off to someone else. What I want is I want you to tell me anything you can about f of x based on this sign analysis chart. Okay? I want you to tell me anything you can tell me about f of x. So start making a list.
There are 1, 2, 3, 4, 5. So that means that x is x to the 5th.
It doesn't have bounce, but it has one of those like
this, where it goes like horizontal for a little bit.
yeah, like
Horizontal tangent, right?
yeah.
Yeah.
And then here it's
Actually, no.
max and
It needs to be 0 at negative.
Remember, you're telling me about f of x, not f prime, f of x.
Oh, wait, sorry.
So we do know that f of x is
And then this one's also at 3. It's gonna have another
Are we
this is what it's gonna have.
analyzing graph what its original function is?
You're telling me as much as you can about the original function.
Okay. So there would be a maximum of -2.
There we go.
there
That's
has to be a point of inflection between -1 and -2. Because if it's 2 bottom end, then there's right?
wait. It's also possible that we have vertical aspect
At 3.
at -4. Because they could just be going up
Wait.
instead of having a tan line. They're both just going up.
But then
Would
wouldn't
that mean the
that
right
mean...
side's negative? Because like if it's like this one's negative, right?
Yeah. So never mind. And I would have made 4 as a I drew the graph. It's like
So wait, what'd you do?
I don't think it'd be undefined.
Well, it says it is, right?
Oh, it does say that.
What does it say?
I didn't realize
Would
it
it be
said that.
Yeah, I'm
It says
vertical
undefined.
vertical tension?
Well, it could be one of those like these ones. Well, okay, let's see. So at 3,
but it's still could be.
I think it'd be a vertical.
Okay.
Like, would it be a negative?
Yeah, just have to keep going out after
Yeah.
until 4. Go back up. My graph is fun.
Oh yeah.
Okay. Somebody pop up. Anybody? Sean, come too. We'll do 2 popcorns at a time. You can draw, you can write, I don't care. Just tell me anything about f of x. Popcorn, someone.
Want to go, Sydney?
Oh, actually, can you guys change marker colors? I've been told that the green on the videos does not show up.
Not very well.
Well, if somebody would have told me earlier, then I would have fixed that earlier.
I never watched this.
Well, okay. Popcorn.
Your turn. I know, I don't want to draw the whole graph. I just want this to
Tell me more.
We all did this together.
There's 1, 2, 3, 4. Yeah. I'm gonna write that.
Like a 0 would be like if it's like if your x out is this, it's a 0, or if it's
1 point up to
this. Don't you, Trevor?
Yeah, I count more than just
I'm gonna cross.
What else?
changes directions.
There's more. There's my second popcorn.
Doesn't it have to be it's your favorite student? Third class, so right?
We'll talk about all of it. We should have 2 at a time. Oh, there we go.
Oh, wait.
Popcorn.
Add 4.
What's a 4?
Oh, yeah.
No kidding. 4.
For what? Oh, yeah. I was doing negative 4%. Wait, when it goes
Ah,
24
there's the words I was looking for too. Increasing. Good.
That's why I rolled around.
Perfect. Popcorn.
It's relative min, right?
Summers doesn't judge spelling. I spell everything wrong.
She's not an English teacher.
I know. Except for anytime someone says she's not an English teacher, I feel bad because I'm like, I want English people to do math in their room, so I should spell better.
Oh yeah, I have to give it to somebody.
More.
I know.
Like you're going.
He saw my paper. He's like,
Okay, anything else people want to write? There's a few more intervals of increasing and decreasing we can add up there. lot of discussion about x equals 3.
Can we change something if we think it's wrong, or no?
No, I want to talk about all of it.
Okay.
I want to go again and do this.
Anyone else?
I want to.
Okay, let's talk.
-3 is a vertical diagonal.
Okay. First of all, good job, by the way. Nobody wrote concave up or down on there, which is great. Because concavity is discussed on the second derivative, not the first derivative, right? So good.
Wait.
Yeah. I heard a wait, so I'm...
I think you can proceed.
Okay, thank you. Yeah.
Can't x at 3 still be continuous?
Maybe.
Yeah, so it's not discontinuity.
Well, it could be, right? So this is what f of x could look like at 3. It could be a discontinuity.
But we don't know.
We know for sure it's non-differential. What type of thing have we done that it would be continuous on f of x but still be non-differential? Anna?
Is that vertical tangent line?
Yeah, I hate drawing these. So it could be like this, or it could be... okay, not bad, not bad.
Should it be like an absolute value?
The problem with it being an absolute value
Go from positive to negative.
is it would go from a positive to negative. Now, maybe it's a piecewise situation where it goes like this, right? Where there's a linear change of some kind that way. Could be a jump. We don't know, right? So it absolutely could be a discontinuity, or it could be a continuous on f of x, but non-differential, right? This is the only possibility for -4, however.
Why?
Because if it's 0, not undefined. So I know that's the only way for it to go flat, but not have an increasing, decreasing change. Okay? This one here, 1 point of inflection, it might be true, right? We know for sure it has at least 1 point of inflection. Where?
-4.
At -4,
But also
right?
something at 3.
It might be 1 at 3, depending on if it's continuous or not, right? So we don't know. That's the whole point. So we know it has at least 1 at -4. It might have another at 3, and it might have another somewhere else in here, right? We don't know. But we know it does have at least 1, okay? Now, could I say that it is increasing from, instead of -4 to -2, what if I said -infinity to -2? Is that true?
No.
No, because -4 is a 0. It's not negative or positive, so it wouldn't include that. So you got to be careful. There's a few more intervals of increasing and decreasing you could do there. That's good. Now, let me just make sure. 4 relative extrema. 1, 2, 3, 4. Okay, I agree. Now, here's the deal. Number 1 most missed question on your last test. It was number 7 on the multiple choice. I read it and my heart broke. Because it was a vocabulary issue. The question asked for maxima. And most of you guys put the right answer for it. The vocab word, it said extrema. What is the difference between extrema and maxima?
It's always max.
Maxima is always the top, always max. Extrema is our word that encompasses both extremes, max and min, right? So be careful. Okay, good. Because we have 2 relative minimums, okay, and 2 relative maximums, but we do have 4 relative extrema, okay? Now, do I have enough information to know if either of any of those relative extrema are also the absolute? Yes, I do. Look, I am increasing from -infinity to -4. What does that tell me about f of x?
Oh.
Not cubic, but it tells me it has no absolute minimum.
Oh yeah, because it's positive slope.
Because it's positive slope from -infinity to -4, right? And then the fact that it's increasing after 4 to infinity tells me it has no absolute maximum. So I now know, because I can make these connections, right, that none of those relative extrema are absolute extrema also. Can anyone remind me what, in terms of the derivative, is the difference between a relative and an absolute extrema? Is there a difference? There's a huge difference. The highest point, but do we care what its slope is? No, right? Literally for absolute extrema, look at your range. It's the highest and lowest point in your range, right? I don't care what its slope is there though. For relative, it must have a slope of 0. It must be a critical value, okay? Okay, ultra lava is out if you don't have them already. We're going to talk about the extreme value theorem.